Well, the ocean's health also contains the plastic pollution. It's a big issue. We all use plastic. Sometimes we can't even avoid it for several reasons, but well, it ended up in the ocean. We have two speakers who can tell us something about that. We have Simon van Gennip, but we will speak to him later. It's a Dutch name, but he's not Dutch, from Gennip. But first, I would like to recall Daphné Lecellier. She's from GEOBluePlanet. She's the program manager, and it's an initiative dedicated to bridge the gap between ocean and coastal observation and societal needs. Did I explain that pretty well?
Perfect.
Correct me wherever you want to. Ladies and gentlemen, Daphné.
Thank you very much. Hi, everyone. I hope you are not already too depressed about climate change, because I'm going to talk to another plenary crisis, so namely plastic pollution. Okay, let's start with a definition from the United Nations Environment Programme. What is marine litter? So marine litter is any persistent, manufactured or processed solid material discarded, disposed of or abandoned in the marine and coastal environment. So marine litter is a very global and transboundary problem. As you know, plastic does not know borders. They cross the ocean, they are carried by a current or the wind. So it's a planetary crisis, and it's also a multidimensional problem. They have impacts on all aspects of our society, the environment, of course, but also cultural. They impact tourism, they have economical impact, and impact on health, human health, but also animals, with associated costs. When we talk about marine litter or marine debris, sometimes we talk about just plastics, because most of it is composed of plastic litter and plastic debris. We're going to talk about ocean. We are in the digital ocean pavilions, but most of the plastics, of course, is carried from the land. Comes from the land, more than 80%. And I give you some numbers from the UNEP report 2021. But as you see, it's estimates. There's a large number, a lot of tons of plastics in the environment, but we do not know the exact numbers. And what is important to remember, it's emissions are growing, and the number of plastics in the environment is increasing a lot. Is projected to double by 2030 by the UNEP report, but I also read a triple by 2060. So it's an increasing and growing problem. Plastics or marine debris are really diverse and a complex problem. They vary a lot in forms and sizes. You have really big fishing gears abandoned in the ocean, fishing nets, and you have really small particles such as microbeads. Think about some toothpaste or cream, healthcare products. Plus, large particles can also break down into micro and nanoplastics because of some physical process, because of UV rays, and in the marine environment. They are found everywhere, as I said. It's a transboundary problem. You can find them everywhere in the globe, in the sea surface, but also in the whole water column and down in the sea floor. So it's very difficult as well to study because they are everywhere. You need to go everywhere in the ocean. It's also complex because plastics varies. There are different types of polymers. Some are associated with toxins or additives that makes them even more dangerous, impactful, and toxic for humans and animals. So a very complex problem to study and assess, and a global crisis. So, in order to solve this problem, countries gathered and they are working towards an international treaty. It started in 2022 with the UN Environmental Assembly 5.2 resolution. So countries gather to develop an international legally binding instrument, so a treaty on plastic pollution. And from the start, it includes the marine environment. So from the title, there were already a focus on the ocean and the marine environment. So the date is 2024. It's not done, but it's in process. It's also important when tackling this issue to take into account the full life cycle of the plastics, so not only the one in the environment, but going ahead, like at the production stage, the design, talking about eco-design, circular economy, and disposal and waste management practices. And this treaty wants to address all of the stage life cycle of the plastic. The negotiations are led by an intergovernmental negotiating committee that has done 5 negotiation sessions. That's the last one, the 5th, took place in November 2024 in Busan, in South Korea. It did not conclude. And the session will continue with INC 5.2 this August in Geneva. So stay tuned about the plastic crisis this summer. Why did it not conclude? The country did not reach a consensus on 3 specific articles. The Article 11 on finance, for financial mechanisms to help developing countries to shift away from plastics. Article 3 on a ban to some plastic products and harmful chemicals, developing a list of plastics that we don't want to see in our society anymore. And the Article 6, a really difficult one on supply, putting a cap on the production of plastics, which is really difficult to negotiate. But on the good side, some countries rallied and gathered in the High Ambition Coalition to end the plastic pollution. 69 and now 70 countries wrote a declaration just before the 5th negotiation session to ask for an ambitious treaty. And then, as we were going along with the negotiation in Busan, more and more countries joined this coalition. So now it's the High Ambition Coalition and Friends. So in December 1st, at the press conference, you had 85 countries rallying the message of ambition for this treaty. And there were really 2 powerful statements made during the closing plenary by Rwanda, asking all the delegates for ambition to stand up in the plenary. And Mexico as well listed nearly 100 countries that were asking for ambition for Article 3 to ban harmful chemicals and plastics. Now let's talk about science. We are here in the scientific pavilions. It's really important to stress the role of scientists that gather in another coalition, the Scientist Coalition, and to help delegates, diplomats to bring science in the negotiations. And the text, so it's the chair text, or not at all approved text, not the final, but you can see that science is here and there in the negotiating text. The treaty will be based or use the best available science. There is Article 18 dedicated to public awareness, research, science. And for Article 3, the list of banned products and harmful chemicals should be based on scientific evidence or technical information, scientific committee. And there is Article 7 about releases, leakages, plastic in the environment that needs, that recognize that data is needed and more monitoring of plastic is needed to help solve the leakages and identify the sources of plastics. But as I told you before, plastic is a complex material, and the way to study it is also complex and diverse. You can use very high technology tools, such as satellites, to observe plastics, drones, or remotely operated vehicles that give a global picture. There are scientific expeditions to have in situ data, very local, regional. Usually they are based on scientific project, answering a specific research question in a specific location, so it's not global data. And really importantly, you have many local citizen science events led by NGOs that helps to gather data on plastics everywhere in the globe. But all that is based on different methodologies, protocols. Each NGO has developed its own way of counting plastics on the beach. And as it's a global problem, you cannot assess plastics the same way in different beaches or in different regions. You don't find the same types of plastics in different regions of the globe. So there is data, but non-unified data sets, and it's very difficult to compare, so to have these global harmonized pictures of plastic. So GeoBluePlanet, my initiatives, is supporting an integrated marine debris observing system that is a network to support the development of a globally coordinated and sustained observing system of marine debris, to monitor plastics in a harmonized way, in a more operational one, and to address the gaps, knowledge gaps for the scientific community, the research, but also help decision makers. And as you can see, there is also feedback loop going back to the societal needs, and the idea is really to design observation to help solve the crisis and help solve societal needs. The idea is to gather everyone around the table, provide guidelines and high-level recommendation towards harmonization of plastic monitoring. This initiative, IMDOS, was born at the Ocean Ops 19 conference, a breakout session on marine debris, where scientists work towards a plan to harmonize marine debris observations. And then it was developed in 2021 as a joint initiative with GeoBluePlanet, GOOS, the Global Ocean Observing System, and UNEP GPML, the Global Partnership on Plastic Pollution and Marine Litter. So from the start, it was really important to have the science, but also these multi-stakeholder groups composed of government representatives, private sectors, scientists as well, to have this link between science and policymakers. And to target everything, the whole value chain of Earth's observation. Yes, and last slide. So we are organized in 11 task teams. The first group is focused on data, so the remote sensing data to microplastics. We have technical coordination activities to help harmonize everything, and engagement activities to support the global plastic treaty negotiations. And we have also an advisory groups composed of many different intergovernmental organizations to have these links with policymakers. And I will go to give the floor to my colleagues.
Hello. Sorry.
Simon van Gennip,
So,
head of the Ocean Monitoring Team.
hello. Thank you very much. So, Daphne talked to you about the importance of observations. I will be looking at the complementary approach, looking at the importance of modeling ocean plastics, and in particular, how plastic modeling can inform policymakers. So, like Daphne said, you can find plastic everywhere in the ocean, from the equator to the poles and from the surface to the bottom. But when you these countless efforts they're made to collate all this information, when you bring it all together and you put it on the map, this is the state of all the observations carried out and mapped at the global level. Closer like this, at the global level. So as you can see, there are many unobserved areas of the oceans. So what we can do with this, like Daphne says, we can look at the plastic density in the ocean, and we can see that, for example, there's large amounts of plastic quantities or density near areas where it's densely populated, or in the center of the gyre where the currents at the surface converge, and as a result, plastic accumulates. So from this, there's a lot of things that we cannot do. For example, have a global budget of how much plastic is at the surface or in the ocean in general. We cannot say where it accumulates exactly. And finally, if we don't have this information, we cannot we cannot inform on good actions to take in order to take this plastic down. We need to be able to measure all of this. And this is when ocean plastic modeling comes in. So what do you need for modeling plastic in the ocean? So first of all, you need good ocean currents that can reproduce the large jets that you can see like here on the Gulf Stream, and all the little swirls, the little eddies and the fronts that are really important to transport plastic. And you need to get their size right, their position right, and their movements right. So this is done and provided for free by the Copernicus Marine Service, and you can go and see the demonstration there to believe it with your own eyes. You also need to know where the plastic enters the ocean. And for this, there are a lot of data sets that document how much plastic comes in the oceans, and these come with their own uncertainties, which are quite large, but this is what we have and what we need to work on. And also, you need to know how plastic behaves once in the ocean. So if we look, once in the ocean, the plastic can carry it away, so it drifts. It can fragment, so a large piece can become lots of small pieces. And it can sink, and it also can end on beaches and then resuspend in the water, and so on. So when we look at modeling ocean plastic, has been happening for the past 10, 15 years, and as much as the earlier models on your left than the more advanced and later models, these capture well the patterns that we saw in the observation earlier on, that plastic converged to the center of the gyres at the surface, and also is dense next to where a lot of populations are. So the models are doing a good job. Now, what have they been saying? So we've been able to get this budget of plastic, how much plastic is in the ocean. So just some key figures for you. So about 0.1 to 3 million tons of plastics are documented to be at the surface. 4 minutes. 8 million tons are entering plastic in the ocean every year, and this quantity increases by 4% each year and is predicted to double by 2030. So the total plastic pollution is about 75 to 200 million tons. So beyond that, what else did we learn about modeling plastic in the ocean, aside from all these big numbers? So plastic, we know where it enters, through rivers and coasts, and it can also travel long distances. So the spaghettis you can see here show you how much plastic can travel in a 1 year's time. And also the importance of ocean currents. So ocean currents are very variable. So whether you look at plastic that enter the ocean in April or in October, it can take very different paths. So it can either stay in the Bay of Bengal, or it can just get out and carry to the west. So as a result, if you get a plastic density map like this, thanks to ocean models, you can disentangle it and understand where all the sources of plastics come from, knowing that the plastic in one given place can have traveled for a week, can have traveled for a month or for a year. So this is how the digital twin of the ocean can come in and help us monitor the plastic and assess the origin of the plastic for a given place. And so we have our ocean currents on the platform, we've got the waves, we've got the tides, they all come into play for the transport of plastic, and we have our databases. And once we enter all of this with our plastic model, we get these solutions. And to illustrate it quickly, this is a simulation. I don't know if the backstage can play it. Here we go. So in green, you've got your plastic from river. In red, you've got your plastics from land. And thanks to this ocean model and the digital twin, we can anticipate where it will accumulate. For any given place in time, we can also better assess the origin of this plastic, and also contemplate having some what-if scenarios and play them out and see what would be the best management strategy in order to decrease the consequences of this plastic. So what's the effect of beach cleaning? What's the effect of cutting a river? So I don't know if I've got the time to illustrate what the demo will show you over there, but if we take the case of Madeira, and we could try to assess how much, where the plastic comes from that's been populated, that's been contaminated in this area for let's say November 2017, if we look at plastic that didn't travel much between 0 and 6 months' time, we can see that the origins are local, but also more remote and come from the southern Spain. And we're talking southern Europe, and we talk about of the orders of emissions of the orders of 65 tons. And if we can also contemplate the origins of more distant sources, such as things that arrived have been traveling between 1 and 2 years, and these come more from North America. And as a result of knowing where plastic comes from, we can then play out what-if scenarios. And this is just an illustration. If we say, what would happen if Europe cut its emissions from what comes from the coast, so the cities, the beaches, by 60%, what will be the impact for Madeira? And we can see that there will be a cut of emissions leaving the beaches of Europe for about 20 million tons in this case. And what about if we instead we focused on the river? What would that be the impact? And then so all of this just comes out, provides some scientific informed information that can help policy. So in this case, it's better that we put our energy on coast rather than rivers if we want to reduce the impact for Madeira. And this can be used, this is just an illustration and a demonstration, but all this information can help in many ways, whether it is to inform the marine strategy framework of the European Green Deal, or to guide the global treaty that Daphne talked about to end plastic pollution, or also to support the sustainable development goals. So last slide. Daphne talked about the importance to harmonize data collection and have operational monitoring. The accurate data will help diverse stakeholders, including decision makers, and to take action based on science, and also that this data harmonization will help science and will help the modeling, and the modeling can be a powerful tool to support decisions. And for this, we need more observations to reduce our uncertainties. Many thanks for listening.
Are there any questions? Ada!
I see that there's like a hotspot of plastic emissions in the Caribbean, specifically Puerto Rico, Dominican Republic, Haiti. Can you comment on that?
So you talk about an area where there is the plastic accumulates?
No, or emissions.
Oh,
If you go back to your slide,
in my demonstration.
in the demonstration of digital ocean.
I cannot go back.
Oh, you cannot go back. Okay.
So was this in the demonstration? Okay. So for the demonstration, I can invite you on the stand, and we can look at this specific case, and we can try to.
There it is.
Okay, one more back.
Yeah, go back to the Caribbean.
The next slide, please.
Arthur, next slide, please.
No, one back.
Former slide, please. One more.
Here we go.
There you go.
So.
Yeah.
So I don't know if you know how the ocean circulation works, but there's a big clockwise movements and a lot of, plastic that gets out on.
We're meteorologists for TV.
The western side of the basin just comes across to Spain. So this shows you the potential, the emissions, but it doesn't tell you how it degrades over time, and the amounts are actually what enters in the ocean that the ocean currents say connects with Madeira. So it's likely that plastic that has been released on that side of the basin in these rough regions, it's not super precise, but will end and contaminate the other side of the basin.
You still look like I don't think I completely understand.
So the question would be, how do we know that's a big emission area? I mean, based on what?
So we know how the data sets exist that inform us on how much plastic enters in the oceans through rivers and coasts. So we know that for any of these areas, there's been estimates being made, and on that basis, when we release plastic in that area, we know how much it carries, and then we know that in the orders of 1 to 2 years' time, the plastic released in the ocean there could potentially travel all the way to Madeira.
Potentially, so it's trajectory-wise. By trajectory, you can go back.
Exactly.
And know that's coming. I've been to Svalbard, far in the north, Spitsberg. And even on the beach, we found bags of chips, Lay's chips. Like, why? It's going anywhere. And it's not put in the ocean there. It's put in the ocean somewhere else.
Yeah, and the ocean is a really interconnected place. So being able to disentangle all this information, modeling is quite helps us in order to get a probability of where it could potentially come from. Because obviously we haven't got the true answer and with the precision of a kilometer.
And a small particle. So it's not a kind of ship's bag made in Puerto Rico and it finds in Madeira. It's not. Okay. Any other questions? Yes, I'll come to you. Brigitte?
Are you putting in the ocean some samples of plastic with a GPS or something to measure where it's going and how it's behaving?
So the technology is not so advanced. So I know there are some, well, plastic are really tiny, but there are projects to try to release some of that, to create these sort of mini Argos or drifters that have like a GPS signal, and to try to see what happens. But most of our knowledge comes from drifting buoys that help us, that are observations, that are buoys that floats at the ocean, and they travel around, and we can use them to see how our models are doing a good job at doing this drifting. And then we use the knowledge of how we're good models to do this job to see how they could disperse plastic.
Simon, is this an open source? Can we at home go to a website and just play with the different kind of reductions, lands?
So this is a demonstration, I remind this.
You have to be here in Nice.
And it's available on the demonstration over there to play. So I invite you to go and have a look there. And it's also on the editor website. So this is an application that people
Which website?
The digital twin of the ocean website.
Digital twin of the ocean website for the viewers online.
It's called Edito. And you have a series of applications. So I invite you to the presentation of Jan yesterday that listed all of them. And people can play and have a look on how a digital twin can help in providing scientifically informed information for decision making.
Well, this is nice for storytelling. So I can imagine people think, oh, how can I put this in my country? Simon, thank you very much. Daphne, where are you? Thank you very much. Thank you. By the way, I'm not telling everybody's biography and what they all did, because we have this booklet and it's also available online. You can watch what everybody does and what the partners are and what the program is. So take a look at this one.